Hello everyone again to my YouTube channel. Today in this tutorial, I will continue the project of house price prediction. So we still working in this dataset of this price prediction. So today in this tutorial, we'll discuss uh, teacher engineering, one of important steps we have in the life cycle of any project of data science. Well, here we have the link of dataset. I will put it in this description, sorry. So to download this dataset from Google. Well, here in this session, we will discuss about missing value, how we can handle the missing values based on this dataset we have. Okay. We will also see temporal variables we have. We'll also see these categorical variables, remove the rare labels. I will show now how we can do that. And the last, standardize the values of the variable to the same range because um, as we see in ADA in the two last tutorials about exploratory data analysis, when we see data set, we have a huge numbers. We have a few numbers like one, two. We have also huge numbers. For this reason, we need to standardize all these numbers or this numerical value in the same range. Well, here in this tutorial, we also need the same packages. We need the pandas to read in our data. We need NumPy here to make some transformation. We will also using this MATLAB Live for visualization, and I make this magic command of MATLAB Live.inline to show my figure and my visualization in the same area. Also, here this syntax is just to show the max possible columns. Okay, the max columns I want to show because here we have maybe is 81 columns. That means we need to display the max columns here. Well, so if we steer here, so we're still working on this train CSV. Well, I create a variable here called dataset. Dataset equal to pd dot read CSV to render CSV. We using also this head function here to return by default 5 top records as we see here in this cell. This is all the values we have. Okay, straight line. So we have different uh, features here. So as we look, we have mixed features. We have some categorical, some other is numerical. Okay, so if we go deep, well, always remember that why always to be chance of data leakage. So we need to supply the data first and then apply feature engineering. Here for this problem of data leakage, that means the model is able to knowing or based or to provide some information, okay, based on the features. So it's so in this train phase, so it's we make us in the overfitting, okay, cause of this data leakage. Just mean we have much information, so for this reason we need to split, okay, to split all data before trying to go in the feature engineering. To do that, so here sklearn provide for us this model of model selection. So from sklearn.model selection import and train this split. Okay, we are creating four variables here. As we see, we have xtrain, yxtest, and ytrain, and ytest. Equal to train this split this function here. We pass the data as we create and we store in this data frame. And in this data frame, have also chosen this price as a target variable we have here. And we want just testing or the test size, we have just 10% of all this data to just to make it as a test. And we have run a state, we assign a 0 because we want just to run it one time. Well, if we go here, also we can see the shape of data we have here. For extreme, we have the shape of 1314 1340 records in the columns. The rows sorry, 81 features. So the same for x test here. So what we do here, we apply to divide in the data we have here, 146 and 81 features. Well, if we go in the bottom, we have here this phase of missing values. So let's capture all the non-value we have here. Okay, the first step we do here is to capture all the non-values. Well, first let's handle category features which one missing. Well, we creating here the features none here as a variable equal to the feature. So in the list comprehensions, okay. Well, feature for feature in dataset dot column. That's mean I want just the columns here in this dataset. If dataset of feature is nil, I want some. It will be more than one. Okay. So we can put here more than zero because we want all the list values. Okay. We can replace one here by zero. And also we need to check in the second part of this condition is to see the data type is equal to big O between the codes. Okay, the types equal to big O between codes. Doesn't mean we want just string types or string features. Okay, we have both conditions here. We need firstly check in the null value, and the second part of this one is to check in the types of all the features we have here. We want just we focus just on the category ones. Well, creating the loops here, as we see, we have four feature in the features none. Okay, we want to loop over all these category ones we create, and we want to print the missing values here. Format feature none round want just four numbers after the comma, and we want the mean for each features we have or each category features. Well, if we look in here, we have array as a feature is the top one here. So we see the most of missing value we have in this feature. We have at least point 93%. Okay, most of data or missing data is in this feature of OI. And we have also these ones. We have ASM quill condition export fin type 1, fin type 2, fireplace code, garage tape. So each of these category will have a percentage or rate of values. So as we see here, we have also in the fence. So the top one is away, the second one is fence. Okay, as we see here, and also we have the miss factor or miss feature here. The top one here is here in this miss feature and away, and we have also this one. We have this fence, and also we have fireplace. Okay, we have some missing value here. So we need some strategy to replace all these value we have. Well, if we so the second part here is coming to building a function. Okay, so this is the syntax how we create or building a function with Python. Anyone also is interested to know about this stuff, so we can go to my playlist of Python and check all these things. Okay, I believe I do that with Python. Well, this is syntax to building a function. We using this keyword of div, and we give the name of our function and the parameters we want. So in our case here, by creating this div replace categorical feature, we have two parameters. The first one is dataset, I mean the original data frame. The second one is the categorical features I choose, feature none. And also I creating the copy from this original dataset. I mean data equal to the data dot copy. Okay, I creating a copy from this original dataset. Also for this data, so for from this copy, I want just choosing this non-value. So data feature none equal to data feature none dot fill not missing. What we do here, just we want to replace all the missing data with this keyword of missing. I will show you now what's happened. So and I will return the new data we have here. So dataset equal to replace catch feature. That means I write in this function here. And inside of this function, I assign this original dataset I have dataset. and also the feature now for categorical one. So they want just to replace the categorical missing value. Well, that's it for feature now equal to nil dot sum here. After running this cell, the cell result will take it. We have zero for all these feature category, and when creating or we apply this function of heat just to return 5 top records. So if we go here, we can see that. Okay, well, I will go to some of alley or fence. See this null value. Okay, let me check it. Well, yeah. So if we look in this feature online, we have missing here. Okay, because why? Because we replace it with here in the syntax of fill now. The function of fill now also help us to replacing the value we want by other one. Well, here in this case, we just replacing the null value with missing. Just to mention it for anyone just coming to run our data and to check in each value we have in each feature. At this time, we can understand we have a missing. Well, well, if we look in, try to go here, we'll create only feature. Well, we have the non value. The original data set we have none. But for us, we want to replace this non value with missing, and that's what we do here. Okay. Now for LA we have missing value. For other ones, each one we have LA and we have for main types. And we have also for this misc feature and we have also for fetch. Each of all these values we replace it with none value. Well, after that, so we want also checking this numerical feature. So we creating this one here, this variable or this data frame again. We have numerical with none. It's a feature for feature in dataset column invested with just features. If dataset feature is none, that sum is more than what? More than one, more than zero. Sorry, because we want all the missing values. And the second part of this condition is to we want the numerical and to return just the numerical features. We want to write in the syntax of that type with this uh, question mark equal to uh, equal to O between quotes. Okay. Well, for feature in numerical with none. So we have this syntax here to just print the rate of missing value we have in those numerical values. So for feature and numerical feature with now, we print in these missing values. That format feature built around the dataset is now the mean. We want the mean of the missing value. We want just four numbers after the, the comma. So for the lot frontage, we have this percentage of the rate of the missing values. Also for the inner area and the with garage built here. Okay. Well, for the numerical value, we have just three features. If we go, we want to replace in again also these missing values. Well, for feature in the numerical feature, we now we were replaced by using median sensitivities of layers. Why? Here I discussed before these topics of outliers, and I tell you, we have one of the famous strategies we have is to replace with median or mean or mod. In this case, why I using this median? Because we have outliers. If we turn before the two last tutorials in this project of house prediction, I discuss in this phase of ADA expert data analysis. I show you a lot of outliers in some variables. So for this reason, we need to use in median. Median is not sensitive to outliers, but for me, it's sensitive to outliers because we are facing the left and the right or left and the right skewed of data. That means the center of data is not in the middle. You cannot get the center of data in the left or the right. For this reason, that means we have outliers, and if we replace it with mean, that means the mean is sensitive to outliers. So to avoid on this problem, we're using the median in this case. Well, for creating a new feature to capture non-values, we are creating this one. We have data features plus none. Okay, we concatenate this string part of none equal to input to where. We're using this where for filtering. We need to check in the condition we give him for our dataset. Well, dataset is feature dot is nil 1 0. That means if we have none value, we need to replace it with 1. Otherwise, we replace it with 0. Dataset feature equal to fill now. We are replacing with median value here based on this one. Okay, here we are creating this median value for each feature. Okay, but this median is not coming for all features. Each feature here we create or have his own median. Okay, for example for year or I don't know I remember. So for this one for loss frontage we have the median its own median, and also for the n area has its own median, and for Gaussian belt has its own median. Okay, and we using this clause of where just to making these filters and replace the null value with one and not if we have not value we replace it with zero. Okay, and we replace all the name value with a median here and we replace it or we confirm this replacement we have here with this clause or this attribute of this interval in place equal to true. Okay, data set numerical with none dot is now dot sum here if we are checking the sum of all values we have in these three features we have 0 1. And if we're running dataset here and we are trying to show 50 impulse 50 elements of that we can see that here so so if we go in the end of our data frame we can check in that. So we have here log frontage none because why we add in these three features. If we look in that where is so mm, oh, sure. So if we look in this syntax, we creating the other ones, dataset feature dot none. That means all these missing values or features, we add in the none. Okay, and we are checking, see if we have 0 in case of non value and 0, 1 for in case of non value and 0 if we don't have. Well, if we look in the end of this data frame, kind of checking that we see. So for aligned frontage none and VNR area none and the RHL build none also. So we have 0 in the most time because we don't have a value. Okay. And if we go to a tell what but okay. Here the idea behind is we're replacing null value with one. And if we don't have, we replace it with 0. Okay. That is the meaning of this. Well, if we go to these numerical values we have here, we have okay, we have the numerical feature. We are putting in this list. Well, for feature in the feature, we have dataset feature quarter in p.log dataset feature. So why we using this log the transformation? Because we have different range of values. Okay, we can have in the sales price a huge value, continue value, but in this lot I will have a few values. For this reason, we need to make all these things in the same range of values. Well, if we after recalling this head again, you can see now if we go to this, okay, let's show you sales price. Okay, the sales price. Look at how it is now, the after and before. So if we look in before, so look at this high price. We have thousands of a number. Okay, we have a huge number here. Maybe it's 100,000s. Okay, but now after transformation with log, look at this number. It's small, and we have all the numbers in the same range of values. Well, to handle also the very category feature, we create this one category feature equal to feature for feature and dataset colon. If dataset feature is type, we want just categorical ones. So, and this is all the category feature we have in this dataset. So we go also for feature the category features. Temp, okay, temp or temporary variables. Temp equal to dataset to group by feature. We want to group all these things by features, and we want to count the number of subscribers we have using this count function attached to this target feature, and we need to divide it by the length of all dataset we have here. Okay. Well, the temp, the frame equal to temp. We want just to apply this filter inside of this temp variable to check in if we have that one. That means we want just to return all temporary variables or temporary values more than 0.01. It's filter inside of this temporary variable until index it. We want to replace it by index. Okay. Data frame, okay, or dataset feature equal to np where the dataset feature is in. We want to check in if this feature or the values we have inside of this feature is in this temporary diff or not. That means if it is in these new values we have, this new values is more than 0.01. If not, we replace it with this value of rare variation. Okay, or rare value var. Okay, rare var. Replace it with this one here, rare var. Okay, if we have this one, it's okay. We still or uh, we conserve the same values, but if we don't have it, we replace it with this one, rare var. After running this cell of this dataset, if we look in now, let's show you someone here. We okay. So if we look in this one here, we have rare. We have here norm and we have here rare because that it not exist. That means we have this value. If we check in the value of this one, it's less than 0.01%. Also for this one, okay, for this house style, okay, we don't have this value. Also we go also here. You see the same things here. Okay, that means all this value is less than 0.01%. That means it's less than 1%. Okay. Well, here for this category feature, we label ordered dataset that group by features. Sales price, we want the mean of the sales price. We sort it. Okay, we make it on order, and we apply on top of all these things the index function here to mention it and to see the indexes we want. Well, for label ordered equal to dictionary, inside of this dictionary we have enumerate function. We have both, we have key and value. For key and value, for key in enumerate labels ordered 0. Okay, if we have the labels, it's okay. If not, we have the 0. Well, the set feature called the set sort by map labels order. We want to map in here after looping over all these data sets. So if we look in now, we have here. So let me show you. Okay, this is for category one here. So here we replace all the categorical value by values by 0 or by some other values. So if we let me check someone here, it's okay. Neighborhoods, okay. Let me show you now. This one, this one here. So after mapping, we replace it with these values here, 1480. Okay, if we don't have any values here, we replace it with 0. Okay, so now we pass to this phase or this step also of feature scaling. So feature scale, call the feature for feature in the set columns. If feature not in ID of source price, that means if we don't have in this okay. So here on this feature scale, we want just all features not in the ID or source price. Okay. Why? Because we want to processing all the features. Well, from this scalar dot processing import means min max scalar. Why we using this min max scalar? We want just to make the range of values more small. We are creating this instance from this model or from this class of min max scalar. We applied scalar, so scalar dot fit. We passed all the data we have data set feature scale. We want to this one here. Okay. After we're running this, we get this value here as we're looking. All this value is between 0 and 1. Okay, all this value of id and sales price is between 0 and 1. Why? Because we want variation to be small, and we won't we don't not or we don't want to have those big numbers of size prediction, for example. On the other ones or other feature we have small values. So for this reason we apply this mix or min max color. So look at this value we have here is between 0 and 1. All the values is between 0 and 1. So if we look into the array, so we have those values is small. Well, now for transform the train and the set and all the ID and access price variables. After transforming, we add in this ID and access price data equal to data tools concat. We're using this concat dataset of ID access price. That means we add in those ID and access price with index drop to we dropped all the one. So df dot data frame scalar dot transform dataset feature scale, and we add in columns features call. The axis one as mean features. Well, after that, so we're looking with me all the values we have here is small between 0 and 1. So for each number we choose in here is between 0 and 1. Okay, with me. Okay, 0 point, we found 0 point. The max value we can get here is 1. Okay, well, we're making all the numbers in the same range of until all the same range of numbers. So that's help us to make our model more robust. Okay, and now we we download the new dataset we have here, data.csv. To CSV here also I used that before in Python list. So to CSV typical to just to conserve the new data we work in. So in this case data.csv I create this one new one here extrain.csv index false. We don't want the indexes, but I store the new values I built here in this variable called extrain.csv. So I hope that's clear for you all. Okay, see you in the next tutorial about the feature selection, how we can use in the selection, how we can use in the features. Because we cannot use in all the features we have. We can just choose in the best one, the best features. The features can impact or has a high impact in the prediction. Well, I will put this notebook in the description. Also, I will put the link of dataset and Kaggle. They mentioned the source of this dataset of house prediction. Okay, it's a famous one. And happy learning for everyone again. Sorry. See you again. Bye bye.